So the next two reference angles, 30 and 60, they're related to each other. Let me just draw this triangle right here. This is going to be an equilateral triangle. So, sorry, this is going to be 60 degrees. This is going to be 60 degrees. And this is going to be 60 degrees because they're 180, and evenly distributed between three angles is going to be 60 each. And we have sides of 2 on all sides, because since all the angles are equal, the sides will also be equal. We're going to drop an altitude right here. This is actually a perpendicular bisector because it splits this length in half, and it splits this angle in half. So I'm going to just redraw this part of the triangle right here. So this guy right here is still going to be 60 degrees because nothing was touched. This is going to be a right angle here. This length is going to be 2. But since this length was cut exactly in half, this is going to actually be 1. Now we can find out what this is by using Pythagorean theorem. So I'm going to say c squared equals a squared plus b squared. My hypotenuse is going to be 2, so 2 squared equals, one of my lengths here is 1 squared plus b squared. 4 equals 1 plus b squared. 3 equals b squared, so that means that b equals the square root of 3. Now we're just dealing with the magnitude, the length, so we're just going to go with a positive one. So I know that this right here is going to be root 3. We know what this angle right here, it's going to be 30. So let's use the lengths that we have kind of made up here and put them onto our two different models here. So the reference here is 30. So 30, what's opposite of 30 is 1. So this length is going to be 1. The hypotenuse is going to be 2. And the remaining length is going to be root 3. Let's do the same thing here. And we know that this right here is 60. This one right here, the angle is 60 degrees because the reference angle is 60. So what's opposite of the 60 degrees is going to be root 3. The hypotenuse is always going to be 2. And my other length is not root 1. Well, root 1 works too. It's just 1. The way that we know this is the shortest length is across from the shortest angle. So this is 30, goes to 1. This right here is 30, this is 1. And then the other one is going to be root 3. So let's now just zero in on the reference angle of 30. So if we were to look at the cosine of 30, which is our x, cosine is going to be adjacent over hypotenuse, root 3 over 2. And our sine of, we can be more specific here. We can say the sine of 30, or sorry, the cosine of 30 and then the sine of 30 is going to be opposite over hypotenuse, which is 1/2. So cosine is going to be root 3 over 2, and then the sine is going to be 1/2. I'm going to use the same colors as I did in the last video, just to be consistent. So in quadrant 2, the related angle is going to be 180 minus 30, which is going to be 150 degrees. This right here from here to here is 30 degrees. That means from 0 to this arm right here is going to be 150 degrees. So I'm just going to use what I know of the cast rule, C-A-S-T. And since they're related, it means that the numbery bits with the sine and cosine are going to be the same. So that means it's going to be root 3 over 2 comma 1/2. But we know that only sine is positive, so our cosine becomes negative. So the cosine of 150 is negative root 3 over 2. The sine of 150 is 1/2. What about in quadrant 3? That's going to be 180 plus 30. 180 plus 30 is going to be 210 degrees. So the number bits are going to be the same, root 3 over 2 and 1/2, but only 10 is positive in the third quadrant, so we know that both sine and cosine are going to be negative. Now do it in your calculator. Put in what is the cosine of 210. Well, the cosine of 210 is going to be negative root 3 over 2, or in your calculator it will be the decimal equivalent of that. And the sine of 210 is going to be negative 1/2. In the fourth quadrant, quadrant 4, we're going to have 360 minus 30 to find the related angle. So that's going to be 330 degrees. So the cosine of 330 degrees is going to be positive root 3 over 2, because we know the cosine is positive in quadrant 4, but our sine is going to be negative, but it's going to have the same value, the same number. Now we're going to do the exact same thing with the reference angle of 30. So let's just dig into what the cosine of 60 is and the sine of 60. And I'll draw in my little angles here. So this is going to be our reference angle, which is 60 degrees. And I'm going to do the exact same thing in all of the quadrants. So I know that this one, yeah, we'll get to that. So the cosine of 60 is adjacent over hypotenuse, which is 1/2. Interesting. Look, the sine of 30 is 1/2. The cosine of 60 is 1/2. The sine of 60 is going to be opposite over hypotenuse, root 3 over 2. What they do is they just flip for 60 and 30. They are they're related to each other. So every x value is going to have the value of 1/2. Every y value is going to have the value, the number bit of root 3 over 2, but then the signs change. So in the first quadrant we have 1/2 comma root 3 over 2, because we know our cast rule, C-A-S-T. Another way of saying is the x-coordinate in the x-coordinate is positive, so cos is positive. The y-coordinate is positive, so the sine is positive. Now this one right here in quadrant 2, the related angle is going to be 180 minus 60, which is 120 degrees. And we know that the number bits are going to be 1/2 comma root 3 over 2. But only sine is positive, so we're going to have negative 1/2 for our cosine of 120. So cosine of 120 is negative 1/2. Sine of 120 is root 3 over 2. In quadrant 3, we have 180 plus 60, so that becomes 140. We know the number bits is going to be 1/2 comma root 3 over 2, but only 10 is positive, so that we know that both sine and cosine are going to be negative. That negative just didn't want to stay. Negative, stay. And our sine. Now in quadrant 4, we have 360 minus the reference angle, which is 60. So that means that our related angle in quadrant 4 is going to be 300 degrees. We know the number bits, 1/2, comma, root 3 over 2, but only cosine is positive, so the sign is going to be negative. And there you have it, folks. We have all of the values. Now, what I have done, or actually what my friend has done, is she has given us all together the unit circle. So you're going to notice everywhere we have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 345, 330. And what we have is all of the different values for those specific cosines. Now you are going to be responsible for memorizing all of these things, but really the only thing that we need to memorize is this first quadrant, because everything else is very similar. So if you look at 60 and 120, the number bits are the same. The only thing that changes is that in the second quadrant, cosine is negative. In the third quadrant, cosine and sine are negative. And in the fourth quadrant, only sine is negative. Now, you're noticing that maybe we have a different way of expressing the ratios for 45. 1 over root 2 is the exact same thing as root 2 over 2. And let me just show you. So if I were to say 1 over root 2, and I'm like, I really don't like that square root in the denominator, I'm going to multiply by root 2 over root 2. This is called rationalizing the denominator. We'll get to this in a later unit, but just so that you know what the process is here. Root 2 times root 2 is the square root of 4. 1 times root 2 is the square root of 2. But we know what the square root of 4 is, right? So we have root 2 over square root of 4, which is 2. So what we can say is whenever you see 1 over root 2, that's the exact same thing as root 2 over 2. So don't be worried about that. So what you're gonna do now is you're gonna fill in all of these values. You're gonna go hunting. So what's the sine of 0? Remember, sine is always your y value. Cos is always your x value. And tan is always your y over x, or y divided by x. So what I want you to do now is fill in this spot, pause it, and I will I'll fill it in too, and you can check your answers. So here we go, checking our answers. So for the sine of 0 is 0, the sine of 30 is 1/2, the sine of 45 is 1 over root 2 or root 2 over 2. The sine of 60 is root 3 over 2, and the sine of 90 is 1. The cosine of 0 is 1. The cosine of 30 is root 3 over 2. The cosine of 45 is 1 over root 2 or root 2 over 2, whatever you prefer. The cosine of 60 is 1/2, and the cosine of 90 is 0. Let's just double check here. Cosine, our x value of 90. Our x value of 90, yes, it is 0. Very good. Now, we remember our tan is y over x. So 0 divided by 1 is 0. The tan of 30 is y, or sine, which is 1 over root 2 divided by root 3 over 2. So we have 1 over root 3. Another way that we can say this is we can go back up to our triangles of awesome here, and we look at 30 and we say, what is the tan of 30? It's opposite over adjacent, 1 over root 3. Lo and behold, look at that. The tan of 45 is 1 over root 2 divided by 1 over root 2, which is 1. The tan of 60 is going to simply be root 3. Going back to our triangle of awesome here, the opposite over adjacent, so root 3 over 1 is simply root 3. And here's the thing, the tan of 90 is undefined because we have our y divided by our x. So the 1 over 0 is undefined.